You might think that a $6 million system costs twice as much as a $3 million system, but when you're talking about a heating system, that's not the case. Let's say a traditional steam heating system costs $3 million, and a geothermal heat pump system costs $6 million. I'm using very rough numbers, but it's the concept that's important. The school pays for any capital improvement by taking out a bond. A bond is a loan which is paid back over a certain number of years, just like a mortgage, and the term for the bond would be 15 years. But the initial cost of the system is only one piece of the total cost of ownership. The other main component is the operational cost. In other words, how much it costs to run the system year after year. For a steam system, the main operational cost is oil, whereas for a geothermal system, it's electricity. The school receives state aid that covers about 1/3 of the installation cost. So using the rough numbers of $3 million and $6 million, the bond payments are about $200,000 a year for steam and $400,000 for geothermal. We know that the school uses about 60,000 gallons of oil a year to heat the elementary and middle school buildings. At $3.50 a gallon, that comes to around $210,000 a year at today's cost. So the total cost of ownership during the first year is $410,000. A heating contractor calculated the school's heating load for us last year and worked out that it would take 512,000 kilowatt hours of electricity per year to heat the school using geothermal heat pumps. We'll round that up to 600,000 kilowatt hours. The school pays 10 cents per kilowatt hour for electricity, so the energy cost is about $60,000. So already, just in the first year, you can see that the geothermal system doesn't cost twice as much. It costs about $50,000 more. The reason geothermal systems are so efficient is because for every 1 unit of energy you put into the system, you get approximately 3 free units extracted from the ground, whereas you can never get more energy out of an oil system than you put in. A geothermal system also provides cooling. The capability is there, you just have to switch it on. This uses electricity, and the heating contractor calculated the cooling load as 318,000 kilowatt hours per year. Since the calculation assumed cooling is required through the entire cooling season, we'll use half this number, which comes to about $16,000. So even when you add the cost of cooling, the cost of the geothermal system is only 15% more than the steam system. We know these numbers are fairly close because we have the actual numbers for electricity usage from the Putnam Valley Middle School, which did a geothermal retrofit in 1998. Their school is 85,000 square feet, whereas the Haldane Elementary Middle School is 90,000 square feet. Putnam Valley's cost for electricity over the last 3 years for heating and cooling has averaged around $82,000. Now let's project these numbers out over 20 years for heating only. The big unknown is the cost of energy. First, let's use a very conservative model. So let's assume oil and electricity both go up by 5% a year. Since we're using less energy with the geothermal system, the cost goes up more slowly, and it takes about 7 years to reach the point where the total cost of ownership is the same. Beyond that, the geothermal system is cheaper, and when the bond is paid off after 15 years, you get a corresponding jump down. Now let's assume oil and electricity go up by 10% a year. In this scenario, it takes only 4 years to reach the crossover point. When you go to 15%, the results are even more dramatic, and that's not too unreasonable when you consider that oil has doubled in price in the last 3 years. There are other unknowns at play. One is the actual cost of the geothermal system. We have rough numbers based on typical square foot costs, but we really need an accurate cost estimate, and that's one of the reasons we need a proper engineering study. Another unknown is maintenance costs. With a geothermal system, everything is brand new and can therefore be expected to operate with minimal maintenance. The steam system proposed by the school's architect, on the other hand, uses much of the existing steam distribution system, which is now over 70 years old, so maintenance costs are an unknown. I hope you found this helpful, and I hope it has demonstrated why a $6 million heating system doesn't cost twice as much as a $3 million heating system, and it can actually be a lot cheaper, but it's all about the price of oil.